Good morning. Good morning. So our topic for today is Integrator and Differentiator Amplifier. Okay. So Integrator Amplifier. So this is Integrator and Differentiator is a combination of resistor and capacitor. So if it is an integrator, so you have the capacitor as a feedback element. Okay. So as you can see here, you have a capacitor here instead of a feedback resistor. Okay, and then you have the RI. So this is a basic integrator. Then how about differentiator? Okay, so if the capacitor is placed as an input element, so we have here capacitor connected at the negative input inverting. So, and then we have the resistor as a feedback element. Okay. So that would be your differentiator. Okay. So let's start with integrator. So integrator basic equation is V out is equal to -1/RC integral of V in dt. Yan. Magaling naman kayo dito, di ba? Integral. Okay,
Yes, ma'am.
Yan. Don't worry, we'll make it as simple as possible. Okay, so this basic equation for integrator. Okay. Okay, so let's apply the equation. Okay, so given an integrator circuit, so you have your calculator with you. Okay, we'll please get your calculator. So let's try to compute for this one. Okay, so given an integrator circuit, so determine the V out at 0.3 seconds after the application of input voltage. So take note, what is our input voltage here? Is it AC or DC? Ano itong circuit natin na to? Class, what is this 2 volts here? AC or DC?
DC.
Okay, so we
DC.
have yes, DC. DC. Paano ba natin ma-differentiate ang AC sa DC? Okay, so if you have a waveform like this, this is also AC, square wave, sinusoid, triangular wave, basta it's going back and forth, so that is AC. Okay, so integrator can have either AC or DC. Integrator and differentiator can have either AC or DC. Okay, so this time let's have an example given the DC. Okay, so given an integrator circuit, determine the V out at 0.3 seconds after the application of V in, assuming the capacitor to be initially uncharged. Okay, kasi ang equation pala natin is it's either you have a plus or minus. Okay, so insert natin. Plus or minus VC. So if capacitor has an initial voltage, okay? But then our assumption is that capacitor is initially uncharged. So determine V out at 0.5. Then after determining V out at 0.3, so determine V out at 0.5 second. Okay, so dito muna tayo sa A. V out at 0.3 seconds. So the application of the equation is -1/RC. So we have R of 100K, C of 0.4 microampere, integral of 2 volts dt. Okay, with limits from 0 to 0.3. So anong value nito, class? Please compute. Anong value niyan? 0.4 micro. What is 0.4 micro? Then, okay, so what's the value of this?
-50.
Ilan? 100K times 0.4 microfarad. Micro is times 10 to the -6, diba? 100K is 100 times 10 to the +3. Okay, 100 to the +3 times 0.4, negative 6. Then inverse. What's the value? Ano nakuha nyo? Negative
15.
15? Any other answer? Just for this one ha, hindi pa buo. Ito pa lang. Yung negative 1 over RC.
25, ma'am.
Okay, so we have 25. Okay, so we have negative 25. Okay, then we have integral of 2 volts. Okay, so 2 volts is constant here. So pwede natin ilabas to. But integral of dt is, ano, class? Integral of dt is times t. Tama ba? T with limits from, okay, with limits from 0 and 0 to 0.3 second. Okay. Okay. Tama ba? Integral of dt is t. Tama ba, class? Okay, so negative 25 times 2. So you have negative 50 times t. T. So 0.3 minus 0, so it's just 0.3 second. So what would be the answer? 50 times 0.3, so we'll have 15 volts. Negative 15 volts, okay? Do we get the same answer?
Yes po.
Okay.
Yes, ma'am.
Okay, so we have V out is negative 15 volts, okay? So, let's see. Question. Ano ba second? Okay. For the second solution, okay, so we have out 0.3 seconds. So expect natin is we'll have an output of negative 15. Okay. So how about okay, for this one. Okay. So given, same given except that we'll have instead of 0.3 at 0.5. So what would be the value of output at 0.5 second? What's the value here?
25 po, ma'am.
Okay, so we now have,
Negative 25.
okay, we'll have negative 25 volts. Okay. Okay, theoretically, you'll have negative 25 volts. But in actual, so what is the supply of op-amp? What is the maximum supply of op-amp? Range of supply of op-amp? 9 to? What's the maximum? 9 to?
18.
From lecture number 1? So you'll have 9 to 15. Okay. So we have 9 to 15. Okay. So ang maximum, so it will cut off even if the calculation shows that it should have maximum of negative 25 after 0.5 seconds. So, but still magka-cut off siya at 15. So the waveform would look like this. So this is your input. Okay. Okay, so since this is a DC, okay, ano ba itsura ng DC, class? You still remember? How does DC looks like? Naalala nyo pa ba? Okay. So DC looks like a straight line. Okay, initially. Ideally, it should be straight line. Okay. So this is, let's say, this is your 2 volts. Okay. So this is your positive 2 volts input. Okay. Positive 2 volts. So your V out is Okay, so at negative 15, at 0.3, so let's say this is the 0.3, at 0.3 second, okay, form again, this is at 0.5. So this will be your waveform will look like, okay, ideally. But then again, since the maximum supply is only up until 15, so what will happen? What will happen, class? 15, hanggang 15 lang. Oh. Yung gastos nyo hanggang 25, ang pera nyo hanggang 15 lang. What will happen? Class? Low?
Clipping.
Yun, makiklip off. Hanggang 15 lang ang kaya nyo, di ba? Yan. So, hanggang 15 lang. Kasi hanggang 15 lang ang supply. Saan ka pa kukuha, di ba? The output is, ang maximum output mo is approximately equal to the supply. Yung supply na yung maximum. Okay? Yan. Not unless you have a voltage multipliers. Okay? So, ideally ganyan, but it will clip off at 15 because your op-amp, if the supply of this op-amp is at 15 volts. Okay? Dual supply siya, diba? Positive and negative 15 volts. So, we'll have it will clip off at 15. Okay? Kahit maging 10 seconds pa yan, 1 second pa yan, so your maximum is only at 15 volts. Okay? Question? Question at integrator? Okay, none? Okay. Ilan na kayo? 24. Pwede na ba ako mag-ano dito? Download attendance list. Yan. Okay, so that's application of integrator if you have a DC input. Okay, but integrator, usual application of integrator is with AC, particularly changing the, what's this, square waveform to another waveform. Okay, so we have a DC circuit here, square wave. So given an integrator circuit, so take note we have the same given. So capacitor is still 0.4 microfarad, R is still, input resistor is still 100K. Okay, so the difference is that you have an input voltage at 2 volts peak, T of 0.2 seconds. So we have a square waveform here. Okay, so determine the V out after the application of input voltage assuming C to be initially uncharged. So we have some formula natin kanina, you still have plus VC, but if C is initially uncharged, so it's just equal to 0. Okay. Okay, initially uncharged. So let's see. Okay, for number 2. Okay, so we start at, okay, may dalawang part to, diba? 0 to 0.1, the input is 0. 0.1 to 0.2, the input is positive 2 volts. Okay, so paano ba yan? So we have, okay, so this is, again, this is negative 25. Since we have the same given, so we can say that this is negative 25 times 0. Okay, the input is 0 volt times T. Okay. Times T. Copy na natin. Okay. Times T from 0 to 0.1. What would be the answer for this one, class? What do you think would be the answer? Class? What do you think would be the answer for this? Hello? Hello? Class, what would be the answer for this? For V out at 0 to 0.1 second, the output is class. Hello? Class? Good morning. Class?
Negative 10 po, ma'am.
Negative 10. Any other answer? Negative 10. Other answer?
0.
0. Of course, it's 0. Any number multiplied by 0 is 0. So you have number
10 taas
here.
pala.
Anyway, nice try. Okay, 0 volts. Okay, so we have a 0. So for 0 to 0.1, the answer is 0. Okay, so next we have, okay, 0 to 0.1, the input is 0. Okay, but for 0.1 to 0.2, the input is 2 volts. So take note, we have a square waveform. Okay, so let's answer for this. Okay, so again, we have, okay. Okay, so negative 25, what's the input now? We have 2 volts and then we have from 0.1 to 0.1 to 0.2. Okay, so the input is from 0.1 to 0.2, the input is 2 volts. So what is the answer now? For 0.1 to 0.2, what would be the answer? Definitely not 0.
Negative 10, ma'am.
Yung negative 10 kanina, ma'am.
Negative 10.
Okay, advance lang. Okay, so we have negative 10. Okay, negative 10. Okay, and of course, if we're going to proceed from 0.2 to 0.3, if input is 0, what would be the answer? What would be the answer? From 0.2 to 0.3. Okay, 0. Okay, so now let's graph. Okay, let's graph the V out. Okay. If you have any questions, please feel free to ask. Okay. Ayan. V out. So, 0 to... Let's put a line. Okay, let's put a line here. Ayan. Okay. So, we have... Ayan. Hindi ko sure kung straight. Straight ba yung vertical line? Straight ba? Okay. So, 0 to 0.1, the answer is, the output is, what's the output, class? 0. Tama? 0. Tama ba? The output is 0.
Yes po.
Okay. But for 0.1 to 0.2, the output is, it reaches what?
Negative 10.
Negative 10. Okay, negative 10. Okay. Plus the VC. So your VC is also 0 volts. Yung previous output mo, this would become your VC. So it's still negative 10. Okay. So from, where are we? Okay. So from 0 to negative 10. Okay. Color mustard. Okay, so this is negative 10. Can you follow? Don't hesitate to ask. Okay. This is okay, so this is negative 10. Okay, negative 10. Okay. How about for 0.2 to 0.3? So what do you think? Is this okay? So this is another question. Okay. Let's duplicate slide. Okay. So from 0.2 to 0.3, okay, the input is What's the input for this one? Input is
0 volts.
0. Okay, 0 from 0.2. Okay, 0.2 to 0.3. Okay, so we have from 0.2 to 0.3. So of course you have, still the answer is 0. Okay, but the previous output, what's the previous output?
-10.
Okay, so that's the but here. Okay, but okay, but there is a previous output which is equal to -10 volts. Okay, so therefore the output is still equal to -10. Okay, so therefore after, so from 0 to 0.1, so the answer is 0, and then it dropped to -10. But then from 0.2 to 0.3, okay, so from 0.2 to 0.3, so still at -10. Okay, so that's how the output waveform will look like. So if you have another input of positive 2 volts, it will slide down to from -10 to -20. Okay. Question.
None.
Okay. Question. None. Okay. 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 So third example for integrator. Okay. So still same given. Okay, capacitor 0.4, R is 100K. The difference is with the, wait. Okay, so this one. Okay, so given an integrator circuit, determine the V out after the application of V in, assuming C to be initially uncharged. Okay, so basically same given, same period. Okay, the difference is with the value of square wave. So it varies from -1 to +1. Okay, what do you think will be the difference in the what do you think the difference in the different input voltage? Okay, so it varies from -1 to +1. So how will it impact the V out? Okay, so let's see. Okay, so we have again, this is -25. Okay, -25 from 0 to 0.1. Okay, from 0 to 0.1. Okay, so but our input is what is our input? -1. -1 volt. Okay, what would be the answer for this?
Positive
Negative
25.
2.5.
2.5. Okay, so we have 2.5 because we have T times 0.1. -25
Ay,
times -1, +25 times 0.1. So we'll have 2.5 volts. Okay, plus VC, but our VC is initially uncharged. So it's just equal to 0. Okay, 0 lang. Initially uncharged. Eh. Okay, then ano pa? Then next is at 0.1 to 0.2. Okay, let's see. At 0.1 to 0.2, the input is +1 volt. Okay, from 0.1 to 0.2, +1 volts. Kanina we have 0 to 0.1, -1. Now 0.1 to 0.2 is +1 volt. Okay, so we have, now at 0.1 to 0.2, the input is +1. Okay, so we have +1. Then we have 0.1 to 0.2. Okay, so what would be the answer here? negative 25 plus positive 1 times t 0.2 to minus 0.1. Okay? So it's still 0.1. 0.2 minus 0.1. Tama ba?
Yes po.
Okay. So it's actually equal to, okay, but your t 0.2 minus 0.1 second. Okay, so we have
2.5.
okay, negative, positive.
Negative.
Negative. Okay, so the answer is negative 2.5 plus VC. Okay, but we have a previous output from 0 to 0.1. So this is our previous output here. But our previous output is positive 2.5. Right? So we have a previous output of positive 2.5. So for our second, we have negative 2.5 plus VC, but we have a previous output of positive 2.5. So therefore, the output now would be equal to, what's this? Is negative. Then we have positive 2.5. So the net voltage would become
0.
okay. So this time we have
0.
equal to 0. Okay. So that is from 0.1 to 0.2. So what would be the output at 0.2 to 0.3? So we'll just copy this, duplicate. Okay. At this time we have 0.2 to 0.3. Okay, 0.2 to 0.3. Okay, so 0.3. Can you follow, class?
Yes.
Okay. Okay, from 0.2 to 0.3, the input is 0.
25. Ay, 2.5.
Let's see. From 0.2 to 0.3, okay, negative 1. Okay. Okay, so this is negative 1. Negative 1. Ba? You have negative 1, 0 to 0.1. Oh, see. 0 to 0.1, the input is negative 1. 0.1 to 0.2, the input is positive 1. And then 0.2 to 0.3 second back at negative 1. Correct?
Yes.
Okay, negative 1, 0 to 0.1, 0.1 to 0.2, positive 1. And now we're back to negative 1. Okay. So this is 0.3, 0.2 to 0.3, 0.2. Okay, negative 1. Okay, so this is 0.3 minus 0.2. Okay, so again, negative 25 times negative 1. So this is negative 1. Okay. So the answer should be
Negative.
Positive 2.5.
okay, positive 2.5 plus VC. Okay, but what was our previous output? 0. Okay, so that would be the that would be your VC. So positive 25 plus 0 plus 0. So the output now is, of course, 2.5 volts. Okay, so our output, if you have an input like this, which varies from negative 1 to positive 1 volts, so it varies from positive 2.5, 0, and back to positive 2.5. So how are we going to draw that? So let's draw. Okay, let's draw the output waveform. So from 0 to 0.1, the output is, what is the output, class?
2.5.
Negative, positive. Okay, So, 0 to 0.1. Okay, positive 2.50 and okay. We have V out. So this will be our 0 level. Okay. Then we have, okay. So from, again, 0 to 0.1. Okay. Then from 0.1 to 0.2, the output is back to 0.
Yes po.
Okay. And then from 0.2 to 0.3, we have back to from 0 to 2.5. So we'll have a, if you have a square wave input, so we're going to have a triangular output. Okay. Question. Question with integrator? Question. None so far?
None, ma'am.
Okay, so now we'll proceed with differentiator. Okay, so actually with integrator you can have sine wave as input. What else? If you have a cosine wave, so let's say this is a cosine wave. Okay, so the output would be sine. Okay, so what else? But the usual input of integrator is square wave, and then it will transform it to triangular wave. Okay. Now, the opposite of integrator is differentiator. Okay. So with differentiator, we have capacitor as input, whereas we have resistor as feedback resistor. So the formula is negative RC differential of input over dt. Okay. So, okay. So the usual application of differentiator is with you have an input of sawtooth or triangular waveform. Okay. So given, let's say we have a triangular waveform here, given that capacitor is 0.1, R is 100K, so what would be your output voltage? Okay. So this is the characteristic of the waveform. So it varies from negative 10 to positive 10. Okay, so it ramps up, okay, positive slope, 0 to 2 seconds, from negative 10 to positive 10, 2 to 4 seconds, positive 10 to negative 10 seconds. So you have a period of 4 seconds. So what would solve and sketch V out? Okay, assuming C to be initially uncharged. Okay. Okay, so for 0 to 2, we have negative RC. So negative RC, what's the value of RC? Okay, RC is 100K times 0.1 microfarad times differential of V in over dt. So when you say dV over dt is actually refers to rate. Tama ba? Rate of change. Okay. So we'll just make this present as simple as possible. So since this is a rate, okay, parang velocity yan, no? Velocity. So we have V2 minus V1 over T2 minus T1. Okay. So paano ba itong V2 minus V1? So let's take a look. It says here, positive T minus negative T over 2 second minus 0 second. So paano ba nangyari yun? Okay. From 0 to 2 second. Okay. So this is our T1, T2. Tama ba, class? And with respect to voltage, so this is our V1, this is our V2. Okay, to solve for the rate of change, so this is V2 minus V1 over T2 minus T1. Okay? So, V2 minus V1, so positive 10 minus negative 10 over 2 second minus 0 second. So, 10 minus negative 10 is 20 volts over 2 seconds. So, the rate is 10 volts per second. So, that is our dV over dt. So, therefore, 100K times 0.1 microfarad times 10 volts per second. So, what is the value? What's the answer? 100K times 0.1. What's the answer? Have you computed for the answer?
100, ma'am.
What's the answer? What's the answer? You get the answer?
0.1.
The answer is 0.1. Okay? Negative. Negative 0.1 volts. Tama? Negative? Okay.
Yes po.
You have negative here. Okay? So we have negative 0.1 volts. Okay? How about 2 to 4 seconds? Okay? So at 2 to 4 seconds, so what is the output? So let's go back to the waveform. At 2 to 4 seconds, so nag-ramp down na yung ating waveform, okay? So this from positive t down to negative t. So this will be, the 4 second would be our t2 minus t1. And for delta v, from negative 10 minus positive 10. So this will be our v2 and v1, okay? So let's see. So our dv is negative 10 minus positive 10. So this is our V2 minus V1. Okay. And from 4 second minus 2 second. So again, our dV is negative 10 minus negative 10. So it's still 10 volts per second, but now we have a negative 10 volts per second. Tama naman yun because, ano yan, pababa. No? Pababa. Yan. Pagpataas, positive slope. Pagpababa, negative slope. Okay? So, we have negative slope here, negative 10 volts. So, kung ang sagot natin kanina is negative 0.1, so expectedly, this should be, what's the value? Positive 0.1 volts. Okay? Yan. So, paano yan? Okay? So, dito tayo. If integrator has this value, it has this waveform, if you have an input of square wave and output a triangular, what do you think will be the output for the differentiator? If you have an input of triangular waveform, what do you think will be the output for this class? Just a guess. Manghula na kayo, sanay naman kayo manghula eh. Na. Yung output natin.
Still 0.1.
Ano yung tsura ng waveform? If integrator
Square.
has a square wave, okay? Because differentiator is the exact opposite of differentiator. So if you have ayan. So this time we have an input voltage here in triangular. So dapat ang output natin is a square wave form. Okay? P out. Okay. So 0 to 2 second, we'll have an output of negative 0.1. Okay, so we have, ayan, negative 0.1. Okay, takpan natin mamaya. Then we have positive 0.1. Okay, so we have positive 0.1. Okay, so mangyayari nga, hindi pa rin pantay, no? Okay, kapalan na natin to. Ayan, so we have, ayan, so we have a square waveform. Tama ba? Question, class, question. Question? Wala? Nagets nyo agad? Nakuha nyo agad yung integrator and differentiator. Okay. So, yan na yun. Okay. Anong value niya? Nagre-range from positive 0.1. Tama, no? 0.1 to negative 0.1 volts. Okay. Ayan. Dali lang, ano? Ayan. Question. Wala na? We're done. Oh, we're done. Wala kayong tanong eh. Ayan. 26, may dumagdag. Sinong dumagdag sa atin? May dumagdag na isa.
Ako po, ma'am. Sorry po.
Apelido.
Villanueva po.
Isley. Okay. So anyway, this is a recorded session. Okay. So I will upload this to YouTube later on. Okay. So I have a quiz. No? And let me see if it is already uploaded here. Wala pa. Okay. So have again an assignment for you with regards to integrator and differentiator. Are you sure you have no question?
Gets naman po, ma'am.
Okay, very good. Again, in a white paper, please. Yan. Assignment. Okay. Due tomorrow morning, ha? Tomorrow lunchtime. Pwede ba yan? Maiba naman. Okay, there you have it. So, ayan. Nakita niyo na ba? So, that's all for now. Okay, buti na lang mga fast learner kayo, no? Ayan, buti na intindihan nyo agad. Okay, clear lahat, ha? Okay,
Yes.
so the PowerPoint is available
Yes,
at
ma'am.
MS Teams. Yes.
Okay na.
Okay na. Okay. So, the materials available at MS Teams. Okay, assignments are also available in MS Teams, so please check. Okay, so that's all for now. Since if you have no more questions, okay, everything's clear. So without further ado, okay, bye.